Today we're going to be proving the volume for any tetrahedron within 3 dimensions to be 1/6 multiplied by parentheses BD vector cross BC vector dot BA vector. In this specific example, or in general terms, the volume is equal to 1/3 times the tetrahedron space times its height. We can first off by letting BD vector cross BC vector to give us BE vector, which BE vector will start at point B and end at point E, which is also perpendicular to the two vectors of BD and BC respectively. From here we can find the projection vector of BA onto BE, which will draw a perpendicular line over to intercept BE at a point of G, letting BG vector being the projection vector of BA vector onto BE vector, which BG vector is also the height, or BG vector's magnitude, that is, as we know that BGAF forms a rectangle, and therefore BG segment is equal to AF segment, which AF segment is the tetrahedron's height. From here, we can assume angle EBA, let angle EBA to be equal to the value of theta. That would be its angle. From here, we can find that BA vector's magnitude multiplied by the cosine of theta will give us the height. Remember, AEB is a right triangle. From here, we can employ the use of BA vector dot BE vector, which is equal to, by definition, BA vector's magnitude times BE vector's magnitude times the cosine of theta, which we know BA vector's magnitude times cosine of theta will give us height. Well, we can substitute that into our equation to get BA vector dot BE vector is equal to BA times cosine of theta becomes H times BE vector's magnitude, which to rearrange the equation to get BA vector dot BE vector divided by BE vector's magnitude. And here we are halfway done with the proof. Then we must employ finding out the base area of a tetrahedron. As remember, the volume formula for a tetrahedron is 1/3 times its base times its height, which in this case our base would be triangle BDC, which would be equal to half times the magnitude of BD vector cross BC vector. BD cross BC vector will give us a parallelogram. Take the half of that and we will get the area of triangle BDC. From here we are ready to apply the base and height into our volume formula, which to rewrite our volume formula to get V is equal to 1/3 times its base, half times BD vector cross BC vector's magnitude, times our height, which we have previously derived to be BA vector dot BE vector divided by BE vector's magnitude. So you write that in accordingly. From here, we combine the like terms of 1/3 and 1/2 to get 1/6. This remains unchanged, BD vector cross BC vector's magnitude. And we know BE vector we previously defined to be BD cross BC vector. Therefore, BE vector's magnitude can be rewritten as BD vector cross BC vector's magnitude. And so we apply that into our equation to get BA vector dot BE vector divided by BD vector cross BC vector's magnitude. Notice these two terms we can cancel out, and then we'll be only left with 1/6 times the BA vector dot the BE vector, which again we have assumed BE vector to be equal to BD vector cross BC vector, which our final result to be 1/6 times BA vector dot BD vector cross BC vector, the exact same formula we have for the volume of any tetrahedron within 3 dimensions, and we can be sure this is correct, as the cross product of two vectors will result in another vector dotted with another vector will result in a scalar quantity multiplied by 1/6 will indeed give us a volume for any tetrahedron.